So I am Matia Muller. I am working on the White Stork and the spatial differences in the demographic parameters. And these spatial differences, I think, can be linked with migration. So the title of my talk is Migratory Strategy Affects Survival and Age at First Breeding of the White Stork. And first of all, I wanted to present briefly like the two different stork flyways in Europe. And the first one is what is called the Western flyway. This Western flyway, so the storks that are breeding in southwestern Europe up north to southwestern Germany, they belong to that flyway. About the migration of these storks, so until the 1980s, most of these storks were doing long distance migration and were wintering in Western Sub-Saharan Africa. And since about the 1990s, there's really an increasing number of storks that winter in North Africa, in the Iberian Peninsula, and now even more and more north. So in Germany, France, Switzerland, now there are lots of storks wintering. Especially in the Iberian Peninsula, these storks, they feed on landfills. So they are using some anthropogenic structures for feeding. And the storks doing long distance migration to Sub-Saharan Western Africa have become less numerous right now. So the majority of storks from this Western flyway do short distance migration. And there is another flyway, which is called the Eastern flyway. And the storks that are breeding from Eastern Germany and Eastern Austria up to Russia, they belong to that flyway. These storks, they migrate through the Middle East and they winter in Sub-Saharan Eastern Africa or Southern Africa. So they can go quite south, up to South Africa. And in contrast to what have been seen along the Western flyway, there have been no change in migration strategy in these storks. So during the last decades, the migration strategy of these storks belonging to the Eastern flyway has remained more or less the same. And what is interesting for me as a population biologist is that there are different population trends per flyway. So along the Western flyway, there have been a decreasing trend since quite a long time. So almost 1 century or even more than 1 century, the stork population along the Western flyway has started to decrease. The decrease was slow or moderate before approximately 1960. And then between approximately 1960 and 1980, there was a crash in the Western flyway population. You can see on the table to the right that the population, for example, if we take the example of Alsace in northeastern France, the population was about 150 pairs in 1960, and only 14 years after, in 1974, only 9 pairs remaining. And the same amount of decline was observed, as you can see also in southwestern Germany. And even if you go more to the southwest, so basically like southwestern Europe, the southwestern tip of Europe, so Portugal, which also belongs to this Western flyway, there also been quite a large decline, although it was less pronounced that more in Germany or France, but the decline has been quite large still. The population was divided by 2. So the decline of the white stork has often been linked with habitat destruction in Europe, especially the destruction of wetlands, because the white stork, of course, they like the wetlands. But this was probably the main cause of the slow decline that has been observed before the crash. But it was not the cause, or only partially the cause of this crash. This crash is probably more linked to 2 factors, one being the Sahel drought that started in 1968, and that is known to have affected long-distance migrants in Europe. For example, there is a common example, which is the common white throat, was the population declined by 70% between 1968 and 1969 in Western Europe. Of course, for the stork, it was not like this. The crash started actually before the drought. So the drought probably explained part of the decline, but not all of the decline. Another hypothesis, which for me looks quite pertinent and quite probably explain quite a large part of the decline, is the decrease of the desert locust availability in Western Africa. So this desert locust is very important for the storks in winter. They feed on that, and there have been some control operations. So on this locust during the 60s, the 1960s, and the 1970s. And these operations has led to a very high decline of this desert locust. This could have like decreased a lot the amount of food available for the storks and thus decrease the survival of the storks. Yeah, maybe also other factors could have contributed to this crash. But then, since the 1990s, there have been a very rapid recovery along this Western flyway. This coincides. Is it just a coincidence or is it a direct link? This will be one of my questions, but this at least coincides with the change in migration strategy. You can see here to the right, the stork population in Germany that belongs to the Western flyway, because in Germany there is one part of the stork population that belongs to the Western flyway, another part that belongs to the Eastern flyway, and here you can see the part that belongs to the Western flyway, a rapid increase. Here it's from 2000, but it started a bit before, so from 2000 to 2023. And in contrast, the population along the Eastern flyway, there have been some fluctuations. It's known that these fluctuations are linked with climatic conditions in Eastern and Southern Africa. So climatic conditions in the wintering grounds, but there's been not really like some big increase or big decline. It seems to be stable since quite a long time. So to the right, you can see the population during the same period in Germany that belongs to the Eastern flyway. And now, so I am a population biologist, and so what we have seen there is spatial differences in population trends. Spatial differences that can be linked with the flyways. So during the recent years, a massive increase along the Western flyway and a population which remained more or less stable along the Eastern flyway. But you have to know that the population trends, of course, they are function of what are called the demographic rates. The demographic rates are or we can also call them the demographic parameters, is basically what explain the population trends. I will present some of these demographic parameters, actually the most important ones. So of course the survival. So the survival is the probability of surviving from one year to another. This is often age dependent. So some age classes, for example, juveniles, they often have a lower survival compared to adults. There is the productivity, which is the average number of fledglings per breeding pair. There is also, in long life species such as the white stork, this age at first breeding, which is the average age of recruitment into the breeding population. And of course, if you're focused on one population, there is also the immigration, so the number of individuals joining the population, and the emigration, the number of individuals leaving the population. These parameters are a bit less important at a large scale, because of course, if you're looking at a whole country, there will be not a lot of exchange with the neighboring populations. If you're looking at a very small scale, so if you take the population in one city, of course, it will be mainly driven by these parameters. And all these parameters can vary across space. So the spatial variation in population trends, such the one we have in the white stork between the Eastern and the Western flyway, is for sure explained by some special variation in some demographic parameters. And that is what I have studied. So I have two questions that I will investigate. Actually, I will mainly investigate the first one, and I will make some conclusions about the second one with my investigations about the first one. But my first question is, which demographic parameters? Is it survival? Is it productivity? Is it age at first breeding? Explain the higher population growth rate of the Western flyway compared to the Eastern flyway. That's my main question. Of course, it can be more than one demographic parameter, but some demographic parameters can also explain nothing. We will see. And the second thing is, how are these demographic parameters linked to the change in migration strategy? So with the trends we see in the demographic parameters, so if we see that survival is higher here than here, will this follow like the distribution of the flyways? And can we make some conclusions about the fact that migration influence or does not influence these demographic parameters? So I did some predictions which are based on the growth rate, which is observed to be higher along the Western flyway. My first prediction was to find a higher survival along the Western flyway, because the Western flyway, the growth rate is higher, and if you have a higher survival, the growth rate is higher, right? Second prediction is to have an earlier age at first breeding along the Western flyway, because when the age at first breeding is earlier, for the same lifespan, you can produce more youngs. So earlier age at first breeding means a higher growth rate. And my third prediction was a higher productivity along the Western flyway, because higher productivity means a higher growth rate. I have tested that with one data set, actually two data sets, I have to say. So this was tested in Germany. Why? Because Germany is on the flyway divide. The study period was from 2000 to 2023. And I have looked at a huge data set of birds that were ranked in Germany, and which were, for some of them, recited as breeders within Germany. Some of them were also recovered dead, either inside or outside Germany. And all these data were spatially precise. So we have coordinates on this data. I had another data set on productivity data. So these were the number of youngs that were produced per pair. These data were not that precise, but still quite precise, so at the municipality level. So it's basically like, I would say like, yeah, it depends a bit, but it's much smaller than a Swiss canton. So it's still quite precise. I will not talk a lot about my models, because the goal here is not really to talk about that. They are quite complex. But you have to know that I have aggregated the data. So I have done different analyses. Here I will show the results of the most recent analysis. I have aggregated the data into 15,000 square kilometers hexagons. And I have done two models. One was a capture-recapture recovery model, which account for imperfect detection, of course, and which account also for spatial autocorrelation. So spatial autocorrelation is the principle that geographically close areas share similar values. And this model allows the estimation of survival. I have considered in this analysis 2 age classes. I have also done some analysis with more age classes, but here I show an analysis with only juveniles and adults, which is the most important. And this model also allows the estimation of age at first breeding and the estimation of some permanent emigration. And I have done another model, which is a productivity model, which also accounts for spatial autocorrelation and which looks at productivity, of course. And I had these results. So focus on that. You have this red line, which is broadly the division between flyways. Of course, the division is not so clear. maybe the division also has moved. So it's an image. Don't criticize a lot that, because I know that this is, I mean, the divide is quite flexible. There are some storks, even during their lives, they can change their migratory behavior. So 1 year they go along the western flyways, the next year the same stork goes along the eastern flyways. This happens, but this is broadly like this. And what I want to show is that both juvenile survival and adult survival are much lower in the east compared to the west, are much lower along the eastern flyway compared to the western flyway. This is in line with our first prediction, right? We can also look a bit at the juvenile survival per year, so the value for each year. And what we can see that apparently at the beginning, the survival of the juveniles were more homogeneous across the area. And at the end, there was an increase along the western flyway, but not that much along this eastern flyway. These are only preliminary results, because here, this is done assuming that the dead recovery probability is the same during the whole study period. Maybe this dead recovery probability decreases a bit. And that, because here it seems there is a trend for an increasing survival, which could be true, because actually the increase along the western flyway, I didn't say that before, but is more than exponential. So there's like the growth rate during half of the study period, the first half of the study period was lower than during the second half of the study period. So it could be explained by an increase of juvenile survival. And here we have some cues on that, but yeah, these are preliminary results. And I can show the same map for adult survival. So here it seems that the divide between the east and the west was already present at the beginning of the study period. But you can see also that there's some variation between years in the survival. That's quite interesting. I have also the results for age at first breeding, and here it's quite striking, because there's really like a huge difference between the west and the east. It broadly corresponds, or even more than broadly, it corresponds quite well to the divide between flyways. The age at first breeding is much later along the eastern flyway compared to along the western flyway. And this is in line with our second prediction. And finally, I have also some results for the mean productivity. And the mean productivity, there are some special differences, but not really linked with the flyways, apparently. So our last prediction, which was to find a higher productivity along the western flyway compared to the eastern flyway, is not really supported. So now I will interpret rapidly the results. So what we have found is that eastern birds, they have a higher mortality than the western birds, and that they start breeding later in their life. And that we have also found is that the spatial pattern, it mirrors quite closely the divide between the two flyways. So there is some evidence that the migration shapes spatial variation in demographic parameters. So there is evidence that the migration strategy, short distance in majority along the western flyway, long distance along the eastern flyway. The long distance seems to be linked with a higher mortality and also a later age at first breeding. And this higher mortality and later age at first breeding leads to a growth rate which is lower, so close to 1 along the eastern flyway, stable population, and growth rate much higher than 1 along the western flyway, population increasing. Also, what I have done is that there are some studies from the past along the western flyway. And you can see, so I have shown the different values they have found in these studies for the different demographic parameters. So the first period is from 1955 to 1960, so before the crash, actually, where the population was slightly decreasing. Then there is the values during the crash, and then there's the values of our study. And what we have found is that survival was a bit higher before the crash than during the crash. And then during our study, it was much higher. It was even much higher than before the crash. And for age at first breeding, the same trend. So it was earlier before the crash than during the crash, but now it's much earlier than both during the crash and before the crash. So this is also some evidence that after the migration shift, because if you remember, I have said that the Western flyway, both before and during the crash, this population was long distance migrant, right? And now it's mostly short distance migrant. So this is also some evidence that this shift in the migratory behavior has led to a higher survival and an earlier age at first breeding along this population. What is interesting also is that in productivity, we don't see that trend. In productivity, what we see is basically like a continuing decline. And this, which is also in line with my spatial results. So I have found that productivity is not really structured by flyway. And here, what I find is that the migration shift has not resulted in a higher productivity, apparently even in a lower productivity, but it's probably not linked with migration, it's probably linked with habitat. So apparently the habitat is still not so good because the productivity still decreases. But as stork is a long life species, productivity is not a very important demographic parameters. Survival explains much more about the growth rate compared to productivity. So this decreases in productivity is not so, does not have a lot of influence on the growth rate. And now briefly, I want to talk about the reasons for the lower survival and later age at first breeding along the eastern flyway. You can also interpret that as reasons for the lower survival and later age at first breeding for long distance migrants compared to short distance migrants, because this is a bit what it is. So first, long distance migration is dangerous and probably much more dangerous than short distance migration, because I mean, there is some electrocution. And of course, there is also some electrocution along the western flyway. But of course, if you migrate longer, there's more chance you get electrocuted. And also the areas along the eastern flyway are quite dangerous for electrocution. Also, there is shooting along this eastern flyway. It does not really happen along the western flyway, especially if they don't go to Africa, because most of the shooting occurs in the Middle East and in North Africa. But if the storks, they don't go to Africa, but they stop in the Iberian Peninsula, they won't get shot. Storks, they can also drown in some water basins. So to the bottom, you have this picture, which was taken in Syria that year. So this is from that autumn, actually, where all the storks you can see there, they have actually drowned into this water basin. And yeah, also, long distance migration is quite costly in terms of energy. So it's known that for recruiting the first time, so to start breeding, a bird needs a lot of energy. And when they do a very long distance migration, they don't have this energy, so they cannot start breeding. Or I mean, they will start breeding, but later. This explains the later age at first breeding along the eastern flyway. Finally, what I wanted to say that some people could think that density dependence could be a mechanism also explaining the rapid recovery along the western flyway, because of course, along the eastern flyway, there's still quite a high density of storks. So for example, the age at first breeding, you can expect that a bird, when there is a high density of other birds, he will struggle to settle because he will struggle to find a good place to build a nest. Of course, if there is no stork, a low density, he can find very easily a good place to breed, right? So this could be an alternative explanation, but I don't think it is something true, because actually with that, we should expect an increase in the age at first breeding when the density increases along the western flyway, because now the density is more or less the same along the western than along the eastern flyway. It's even probably a bit bigger along the western flyway. It has increased so much. But the age at first breeding is still much earlier now along the western flyway compared to the eastern flyway. Same for the survival. There's no decreasing trend in survival. So there's no sign of density dependence in both survival and age at first breeding. This is why I think these parameters are really very well explained by the migratory behavior. Okay, so now I'm close to finish. Just I wanted to tell a bit, or like to think a bit about what is going to happen in the future. So first, I said before that the border between the flyways is not as, I mean, it's not like the border between France and Germany. It's something flexible. It's something that can also move. And there is some evidence that this border between the flyways is moving toward the east, because the Western population has this really like is exploding in terms of demographics. So there's a lot of dispersal occurring from this population, and these dispersing birds, they go, some of them, they can go settle along the eastern flyway, and probably some of them, they will retain their migratory behavior and still migrate west. So there is some evidence for that, quite strong, which could also explain a sort of slight tendency that appeared a few years ago in Eastern Germany of an increase of, as if there was the beginning of an exponential increase there, which could be maybe explained by the fact that some of these birds now breeding in Eastern Germany belong to the Western flyway. But this has still to be explored. It's not. So there is some evidence, but they are not so strong, I would say. Also, it's interesting because interesting. So the European politics now is to close the landfills. And as I have said, most of the storks that winter in the Iberian Peninsula, they feed on landfills. So what will happen if these landfills close? First, will there be enough food to sustain all the wintering population of the storks? Second, if there is not enough food, what will happen? Will the stork just die? Or will the stork just say, okay, before we were migrating to sub-Saharan Africa, let's do that again? That we don't really know. Third, it's also interesting to think about the impact of climate change on the demographic of storks, but it's difficult to do some predictions about that. First, because, as I said, most of the population dynamics of the storks is actually linked with not what is happening in Europe, where we have some strong climatic predictions, but mostly with what is happening in Africa. And in Africa, I think the climatic models, they are less precise. There are some areas we don't know if we have to expect more roof or more humidity or both of them together, because it can be also both of them together, but it's not so precise, and with that it's difficult to make some predictions. Also, it's difficult to make some predictions because we know that storks can adapt quite rapidly, so maybe if one area becomes like, completely bad for them, they can probably try to find some new migratory strategy. And finally, the last questions, which is also quite interesting, is that could eastern stork change their migratory behavior? Why we have observed only the change in migratory behavior along the western flyway? There's some evidence that they could, because there have been, during the 70s, I think, there have been an attempt of wintering in the Middle East. I mean, there are still some storks wintering in the Middle East, but it's a very, 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 very small portion of the total Eastern flyway population. But during a few years, there have been an attempt of wintering of more birds in the Middle East, especially in Israel, because they had built some ponds for fishing, where there were lots of storks that were coming for also fishing, actually. But these ponds didn't last for long. So they were, I don't remember for which reason, but they were basically like removed after a few years. And then after that, storks stopped to winter there. But it shows that they are quite, they can adapt quite rapidly to some new conditions. And for me, makes me think that at one point, maybe they will start also change their migratory behavior along the eastern flyway. So this is now the end. So I have found that the shift in migration strategy along the western flyway has increased survival and advanced the age at first breeding in German white stork. As a consequence, the growth rate along the western flyway increased, and this allowed this population to recover fast. And in opposite, along the eastern flyway, the mortality remains higher, and the age at first breeding remains later. This is not really linked to some density dependence, at least to my opinion, but I think that even if the population growth rate here is close to 1, I think this could be improved by, for example, preventing the shooting or the drowning or electrocution or other causes of mortality. So thank you very much. I wanted to acknowledge these people. So my supervisor and Fabian, which is working with me, which have helped me in data analysis. I wanted also to thank Wolfgang Fiedler, Olaf Geitet, and Christoph Hermann, which are from the 3 ringing centers in Germany that have collected and shared the data, the ringing and reciting data with us, and also the NABU for the productivity data. And I will do a rapid summary in French. Donc, je vais faire un résumé rapide en français. Sorry for the people that don't speak French. It will be fast. Donc, j'ai expliqué qu'il y a 2 trajets migratoires distincts en Europe chez la cigogne blanche. Un trajet à l'ouest, Western Flyway, et un trajet à l'est, Eastern Flyway. Celles de l'ouest, elles ont modifié leur stratégie migratoire récemment. Donc, elles hivernent plutôt maintenant en Europe du Sud ou en Afrique du Nord, plutôt qu'en Afrique subsaharienne, alors que les cigognes de l'Est, elles hivernent toujours en Afrique subsaharienne. Et moi qui suis un population biologist, un biologiste des populations, donc intéressé à la démographie, j'ai été intéressé par cela parce qu'on voit que la tendance de la population est différente entre les 2 flyways, les 2 zones de migration. Donc les individus qui migrent vers l'ouest, leur population a augmenté très rapidement durant les dernières 20, 25 ans, 30 ans disons. Alors que la population qui migre vers l'est, donc ici c'est en Allemagne, l'Allemagne est située sur le point de division entre les 2 zones migratoires, celle qui migre vers l'ouest et celle qui migre vers l'est. Celles qui migrent vers l'ouest étant maintenant des short distance migrants, donc des migrateurs à courte distance. Celles qui migrent vers l'est sont des migrateurs longue distance. Toujours. Donc ces migrateurs longue distance, leur population est stable. Les migrateurs à courte distance qui migrent vers l'ouest, leur population a vraiment explosé dans les derniers 30 ans. Et moi, ma question, c'était pourquoi y a-t-il de telles différences de tendance? Et moi qui suis un démographe des populations d'oiseaux, j'ai pensé que ces différences est-ouest sont certainement dues à des différences est-ouest dans les paramètres démographiques, donc soit dans la survie, soit dans l'âge de première reproduction, soit dans la productivité. Et je me suis aussi demandé si ces différences démographiques, elles peuvent être mises en relation avec le changement de stratégie migratoire, parce que cette explosion, chez les oiseaux qui migrent vers l'ouest, elle a été vue qu'après le changement de stratégie migratoire. Donc j'ai fait un modèle spatial focus sur l'Allemagne, parce que l'Allemagne, c'est sur la division entre les oiseaux qui migrent vers l'ouest et ceux qui migrent vers l'est, pour évaluer les différents paramètres démographiques. Et ce qu'on a trouvé, c'est que la survie, à la fois des juvéniles et des adultes, était plus basse à l'est qu'à l'ouest. Et on a aussi trouvé que l'âge de première reproduction était plus élevé à l'est qu'à l'ouest. Donc elle commence à se reproduire plus tard à l'est. Donc les longues distances commencent à se reproduire plus tard que les courtes distances. Et donc j'ai interprété ça comme le fait que la migration à longue distance est plus dangereuse. Il y a une mortalité plus élevée en Allemagne de l'Est, où ce sont des migrateurs à longue distance qui migrent vers le Moyen-Orient et vers l'Afrique subsaharienne, alors que les migrateurs à courte distance de l'Ouest, ils ont une plus grande chance de survie. Aussi, la migration à longue distance est énergivore, et on sait chez les oiseaux que pour commencer à se reproduire, pour se reproduire pour la première fois, il faut avoir pas mal d'énergie emmagasinée. Donc, les oiseaux qui migrent à longue distance, ceux de l'Est, eh ben, ils auront moins d'énergie quand ils reviendront parce qu'ils ont une migration très énergivore et donc ils vont pouvoir commencer à se reproduire seulement plus tard par rapport aux oiseaux de l'Ouest. Donc la conclusion, c'est que la stratégie migratoire différente entre les oiseaux de l'Ouest et ceux de l'Est impacte significativement la survie et l'âge de la première reproduction. Et finalement, ceci, ça explique la tendance démographique différente entre les deux populations. Merci beaucoup. Thank you very much.